And now for something completely different. We are not going to talk about storage or exascale or anything like that. I'm Melyssa Fratkin. I'm the Industry Programs Director at TACC. There are many of my partners here in this room. I'm very happy to see you. What we're going to talk about is one of the things that certainly BP and some of the other partners have been very key to use when working with TACC, which is our access to the students at UT and the training and workforce development efforts that TACC has put in so that we can support both our industry partners and all of our academic partners across the country. We have a variety of education and workforce programs. We do everything from undergraduate classes for credit in the university to training and internships and research experiences so that we get across the spectrum from undergrad all the way up through professionals some assistance in learning more about high-performance computing in all its various ways and guises. So there is a Department of Statistics and Data Science at UT Austin. The math people didn't get along with the statistics people, and the computational science people didn't get along with the computer science people, so we kind of became the bastard stepchildren together. So statistics and data science. It is a dual-listed undergraduate and graduate programs, and you can actually come out of UT Austin with a certificate in scientific computation, which is the equivalent of a minor if you take about 5 of the classes, including the ones that TACC offers. So we are teaching C and C++ and Fortran every semester, and every semester that class is full. The PIs and the other researchers in other places around UT have noticed that we have this and that their students need it, and they send them to us. In fact, one of our other partners, Chevron, funded us a couple of years ago to actually take the courses and make them into modules that we can then distribute for free. They're open, they're available. If you guys want them, let me know. And those can be taught in other schools or dropped into another curriculum as a single piece, just to add some complexity. So we do everything from, as I said, Fortran and C, up through scientific and technical computing. What do you use it for once you've learned how to program it? Parallel computing for scientists and engineers, which is that sort of the next step beyond that. And now in the Department of Computational Engineering, we're also teaching scientific computation and software engineering and design, which has become another big thing in advanced computing. Obviously, software engineering is a big thing. We have our industry partners support what we call STAR Scholars, which is the interns who come in and will work with a TACC person as their mentor on a project that is of interest to the partner so that everybody gets something out of it. The students are then encouraged to submit papers and posters to other conferences. So SC, I think this is Madhav, and he actually submitted a paper and was selected for a poster at SC a couple of years ago. So a couple of our partners have funded that. We have additional undergraduate internship programs funded by the National Science Foundation. So once you have a big grant like we have Stampede and now Frontera, you put in for an REU and they send 10 students, and the students we have working with us are in doing weather forecasting and drug delivery and all the different projects that we have. They get to support, and they come in and stay in Austin for a couple of months and work on that. We have a lot of training courses. This is an eye chart, but the important link at the bottom is learn.tac.utexas.edu, which is our training site. All of the materials from all of the past training programs are also there. And there's a YouTube channel, actually, that shows all of these videos so you can follow along at home. All of our 1- and 2-day trainings are webcast, so you can either come to Austin, and why wouldn't you want to, or sit in your office and watch the webcast from home. It's up to you, but Austin is more fun. Anyway, and then we have these immersive training institutes. We started with a single summer computing institute that was 1 week long, and we have now broken that out into more than a half dozen different 1 week, 2 or 3 day, I put an asterisk because some of them are only 2 or 3 days, but 2 or 3 day training or full week training programs so that people can come and learn. We've added on this year, for those of you who've participated in these before, we've actually gone sort of backwards and to lower level, more necessary training topics. So we're starting with applied parallel programming for a couple of days, and then computing foundations, and then essentials of advanced computing. And we are also doing then designing and administering large-scale systems. So this is actually hands-on sysadmin training. Most people become a sysadmin and they go in and they learn on the job. And we're very happy to have them do that. But wouldn't you like to have somewhere where you could send them and have them learn how to build a rack and connect it and program it from the beginning so that they had that when they walked in the door? Scientific visualization, obviously. The biggest training we had last year was machine learning foundations, which we did in collaboration with Intel. And then the HPC Leadership Institute, which is at the end of the summer in September. It's still summer in Austin in September. Which is co-presented with Andrew Jones from NAG. And we do the sort of the ROI, the RFP, who are your stakeholders, all of that kind of instruction, so that if you are a staffer at an HPC center, or you have staff who want to then become managers, or you want to see them move up the chain, this is a good training program for them to learn all of those things that they will need to learn. So this is my list of industry partners, my NASCAR slide. And I'm going to focus on exactly one of them because he invited me here. So BP has been a STAR partner for basically as long as I've had a STAR program, which is nice. And they've funded a wide range of programs, partly I think because Keith recognizes the need to fill the pipeline, because people are going to start retiring in all of the industries that are using high performance computing, and it is really necessary to have people who can fill those voids. So we start with a high school coding competition where we have a group of high school kids come in and 3 or 4 kids in teams learn how to solve a problem, and we give them awards. We have our student cluster team, which goes to SC every year and had won the cluster challenge 12, 13, and 14, so hopefully we'll get back into it this year. As well as I said, the graduate and undergraduate student interns who work at TACC. Keith has actually identified interns based on interviews that they've already done at BP, and so he will say, hey, we have this kid, we want to have him come and work here, can we have him work for you for a while first? Yes, of course, absolutely. So we put them in internships. We have an intern right now who is working on TACC Stats, which is our cluster monitoring software, and so he's learning how to work it at TACC so that they can then learn how to install it at BP and make it work, which is great for both of us. And it's, again, another open source thing that's available for everybody. And so we choose projects that are mutually beneficial, and the student comes in and gets a lot of experience and gets to sort of hang around and have lunch with all the smart people at TACC, which is good for them too. And then they get to go for the summer or for a job to BP in Houston and hang around with all of those smart people. So it's really helpful. Actually, my favorite story is there were a couple of kids that Keith sent us a couple of years ago, and they worked at TACC for the spring semester, and they went to BP to do their summer project, and they gave them the project that was supposed to take the whole summer, and because of everything they learned at TACC, it took them 3 weeks, and then they had to find something else to do. So it's not a bad problem to have. So we would very much like to do that. One of the other things that Keith does and that the BP folks do is they come for expertise. They come to pick the brains of the TACC people. We have generally cutting edge or more of or newer processors, networks, file systems, all of those things, and have generally tried to solve all the problems that the people with smaller installations are going to have. And so when you have that problem and you can call somebody and say, hey, we just hit this roadblock, what did you guys do to get over that? That's something that our industry partners generally very much enjoy being able to do. And of course, he regularly sends people to our training courses and institutes because that's the best way to get them trained up. So, and now a shameless plug for my alternative universe, which is Women in High Performance Computing. For those of you who have staff who might be interested, or if you might be interested, please feel free to come and join. There's a wonderful workshop. There'll be one at ISC. There's always one at SC as well. And we have a Texas state chapter for Women in High Performance Computing, which encompasses a lot of wonderful organizations and a lot of in cities all over the state. So if you're interested in that, please let me know. And just so you know, yes, Frontera has started arriving. I know the Dell people will be happy to see that there is a picture of Frontera on our loading dock and the boss standing there directing things, which is what he does. Anyway, and that's it. Thank you. Let me give you the mic.